We have developed networking as a way to share resources and information, and how that's achieved directly maps to the particular architecture of the networking operating systems that we have been using. Now, in this lecture, we are going to talk about the most common known application architecture, that is peer-to-peer architecture. There are two main network types that you need to know about. The first one is peer-to-peer and the second one is client to server, which you're going to see in the next lecture. And by the way, it's really tough to tell the difference just by looking at the diagram or even by checking out live video of the network. But the differences between peer-to-peer and client-server architectures are pretty major. They are not just physical differences, they are logical differences too. Now you'll see what I mean in a bit. So what is a peer-to-peer network architecture? Well, computers connected together in peer-to-peer architecture do not have any central or special authority. They're all peers, meaning that when it comes to authority, they're all equals. For example, your group of friends, right? No one has the authority to judge you or to decide who is greater. But when a teacher enters in a classroom, then teacher has the overall authority. That is an example of client-server architecture. Then the authority to perform a security check for proper access rights lies with the computer that has the desired resources being requested from it. Now, it also means that computers existing in a peer-to-peer network can be client machines that access resources and server machines and provide those resources to other computers. Now, peer-to-peer network architecture is perfectly fine for less number of hosts, but if you're trying to have more than 50 or even 100 computers in a peer-to-peer network architecture, then it becomes a tedious task. If your network is running Windows, Mac or Unix in a local area network workgroup, you have to have a peer-to-peer network. Now, when it comes to peer-to-peer architecture, security is not centrally governed. Each and every user has to remember and maintain a list of users and passwords on each and every machine. Worse, some of all those important passwords for the same users change on different machines, even for accessing resources. It's a total mess. And since every user has to remember the usernames and passwords of other computers, a lot of memory is required in this type of architecture. For example, as you can see on the screen, this is an example of peer-to-peer network architecture. Now, Millie, Pluto, Mikey, and Louis are four types of users, and as you can see on the screen, each user is storing the passwords of remaining three peers. Now, for example, if Pluto wants to access the resources of Mickey, then Mickey has to remember the password of Pluto. This is such a mess. Now, this seems okay for 4 computers, but what if there are hundreds, thousands of computers? Then is it possible to store all the information in 1,000 computers of each and every peer? No, that would take up a lot of time and a lot of memory. We do not have that much of memory just to store usernames and passwords. And to tackle this problem, client to server architecture is used in today's most of the business applications. In the next lecture, we will have a look at client server network architecture.